Okay, so we have a rail slide here and we are looking for the induced current. And the induced current, let's see, we have a resistance here. So thinking to Ohm's law, and really all we need is a voltage. And the voltage here is due to the induced EMF. So that seems like a good place to start. So EMF. And we can solve this in a couple ways. One is we can go right back to our most typical form of Faraday's law and EMF solving formula here. And we have the change in flux over the change in time. And we know that the n is just one. There's just one loop and we won't worry about direction here. And we'll say the change in flux over the change in time. And flux being BA. Well, we know that the B, or the magnetic field, is constant here, so that can come out. And the area is length times width, with the length just being the length of the bar, so that's a constant. So it's just the width that's changing. And the width is changing simply because this bar is sliding along at velocity v, so that means that the change in width is just due to that velocity. And we can just exchange that with V delta T. And all over delta T, and our T's cancel out, and we're just left with BLV. And that doesn't surprise us because if we would have thought about motional EMF, we could have said, well, it's just like a bar moving along there, and that moving bar is what induces this EMF. So we could just go to that equation, which is the exact same thing, and start plugging in numbers here if we wish. And so we have 0.75 Tesla and 1.5 meters and 5 meters per second. Just using the numbers, we'll make sure we consider the sig figs in that last step. And we multiply these out and we come up with 5.625 volts. All right, so we have a voltage. So now we should be thinking about Ohm's law and our arrangement looking for current I equals V over R. And in this case, our V, our induced EMF, 5.625 volts all over, and our resistance we look up is 10 ohms. And so dividing by 10, nice, just move that decimal place over, and we have 0.5625 amps. And at this point, we should look back and sig figs point of view, everything is 3 sig figs. So that means our answer, just due to multiplying and dividing and such, should be 3 sig figs. So 0.563 amps. And that makes a good final answer for us.